Now, today we shall be looking at some important components from the transformer architecture. The transformer architecture has revolutionized the field of natural language processing and now is beginning to gain momentum in computer vision. So this architecture looks complicated when you look at it here in figure 1, but in code we would like to look at some of the pieces that make up this architecture so that we can have a better understanding of them. So using code, we're going to do that. So let's start from the simplest ones. We're going to start today looking at the add operation. So this is the add operation. Now we're simulating what's happening in the add operation. Let's say we have two inputs. Here the input 1 is an array, or we say it's a one-dimensional vector, it's a vector with 16 dimensions. So a 16-dimensional vector, that means it has 16 elements. Then the second input is a 32-dimensional vector. Now, because this has 16 dimensions, this has 32 dimensions, you cannot perform a add operation on this. So the add operation can only be performed if the dimension of the input is the same. So to achieve that, we take this first input, we pass it through a dense layer, and so that we can use the dense layer to reduce it from 16 dimension to 8 dimension. We do similar thing for input 2. We pass the input 2. As you can see here, this is a functional uh, programming in Keras. So functional model, we pass that into dense layer so that we can also bring it down to 8 dimension. Thereafter, so the two output coming out, x1 and x2, are now having the same dimension, which is 8. Then we can now perform the add operation from Keras dot layers, and we add, and we put the input in a list. So we're adding the two, x1 and x2. Of course, if we have more, up to x3, xn, we can continue to add them. Then once we are done, the result which is added can be further. This added is going to have a dimension of 8 because the input and output of the add operation is of the same dimension. Then this 8 is passed to another dense layer that has an output of 4. So the output of this out is going to have 4 dimension. So, and this is how we create our model in functional Keras. Input, we put all the set of inputs, which is 1 and 2, in a list, and in this case we have just one output. We put that output equals to out. So if we run this and we print our model summary, you will see here that this actually gives us what we're talking about. So you see the output, the final output is 4, and because we have the dense to be 4. And you see our input, we have two input. The first is 16 and the second is 32.
Sorry, I didn't quite hear you.
Sorry
Could you
about
please
that.
repeat what you said?
So then we have the, sorry about that, the 16 and this is 32. Then we have this dense, which is 8 and 8, which we mentioned earlier here. Then the addition gives us back 8 because we are adding. Now you see that during the add operation there are no learnable parameters, so that's the outcome. You can see that in a graphics format. So you could see that the two inputs are different. In some applications This input could have been transformed into a word embedding in natural language processing, and this input could have been the corresponding image in transform and flattened in computer vision. So let's say we are doing a kind of image captioning. So we give the image and its corresponding captioning, and that could come in. And you, as you can guess, right, if we can have multiple captions for a single image, so that means we can continue to add more captions into this input. So at one point, after doing some operations separately, we can now combine the two together using the hard operations. Then we go on and feed it forward until it gets to the final layer, depending on what classification we want to do with our input. So to nail it down and for us to see it very well what's happening, so I've used the numpy to generate values here. So here I'm generating 2 rows and 3 columns. That's a tensor. So you see here that this is the tensor x1 and x2. These are the values in x1 and these are the values in x2. But when we perform the hard operation to give us y, you see the y is actually giving us the same shape as the input, which is 2 by 3. And you can actually see here that 2 plus 2 gives us 4, 2 plus 1 gives us 3, the last one 1 plus 4 gives us 5. And so that's the add operation, and that is an important piece in the transformer architecture. All right, thank you very much and see you in the next one.